So today we are going to talk about Traffic Manager and Azure Web App. Okay. So you're already aware Traffic Manager means I just gave the introduction. Traffic Manager means it is the DNS based load balancer. Okay. So Traffic Manager is a DNS based load balancer which will enables you to distribute the traffic optimally to the servers across the global region. So when you browse an application, say for example facebook.com, when you browse www.facebook.com, the initial query will go to the DNS to resolve host name to IP address, right? And that DNS will decide to which application servers I need to send the request. That is called as DNS based load balancer. So today you're accessing the application in India. When you browse www.facebook.com, the DNS will identify that you are in India and it will send the application request to the nearby application server. So tomorrow on a business trip, you're traveling to some other location, maybe UK or US, and there you are browsing www.facebook.com. Then the local DNS will identify there is a location change, and that will not send the application request to the Indian server. It will send to the local server, which is there in US or UK. That is what the traffic manager does. So basically, a traffic manager is a networking services. It will increase the high availability or it distribute the application traffic to the respective local application servers, and that get decided based on the DNS servers. Okay, so there are a couple of features in the traffic manager. The traffic manager increases the application availability. So it is the higher version of the load balancer, I could say. So we have multiple features, right, to increase the high availability, applications availability. So we have availability set for the hardware redundancy. We have availability zone for the physical data center redundancy, and then we have load balancer. Okay, and then next is we have traffic manager. So the traffic manager is a global DNS based load balancer, I could say. Okay, and it increases the application performance. Why? Because it is not sending you the application request to the original application server. It will distribute the load to the local application server which is close by to you or which is closer to the DNS server. Hence, the application performance will always be better and you will get the better response from the application. And the traffic manager makes sure it redirect to the right application server based on the conditions you define. Okay, either the performance will be very good or the latest latency should be less. It will make sure like that. Okay, and and perform the service maintenance without the downtime. Means if a traffic manager identifies there is an application server having some issue, it will just ignore that application server from the distribution. So imagine you are today in India, tomorrow you are traveling to US, as I gave an example. Within the US, you may have around 10 application servers. The very nearby application servers may have some issues. Hence, the traffic manager will ignore that application server and redirect the your application request to the secondary or third application servers, which is there close by to you. So during that, I mean, by making like this, it will ensure the service maintenance and all will be taken care automatically. Okay, then the traffic manager works at the DNS level. I told you, right, it's a DNS based traffic manager. It is a DNS based load balancer, I could say. Okay, so these are the features of traffic manager. If you want to see or imagine picture wise, you see here pictorial representation. See, I have a traffic manager on the top here. This is the pictorial representation. When you see this image, that means it's a traffic manager. So you have a traffic manager, and if you look at, there are 4 application servers. We have web applications. This is an app server 1, app server 2, app service 3, app service 4. And if you look at in the Europe only, you have 2 application servers. One is North Europe, another one is Western Europe, and another one is East America and West America. So there are 4 different Azure region, you have deployed four different, the same application servers, and all the four application servers you have added behind the traffic manager. So, but in case of load balancer, it was not like that. If you build the load balancer in the Western Europe, you should keep the virtual application servers within the Western Europe only, or within the region only. There are certain conditions depend upon your standard or basic queue. There is some limitations, but in case of traffic manager, there is no regional restrictions. You, because it's a global, when you create the traffic manager, it is not specific to the region, it is a global service. Okay, and the applications or the servers, whatever you add behind the traffic manager, can be any of the data center or any of the region. Okay, there is no regional restrictions. Okay, this is the pictorial representation. Okay, so there are multiple routing methods we have. So when you build the traffic web, what is that, the load balancer also you will create some rules. Correct? Now you will decide. Okay, but when you deploy the traffic manager, you have to define some certain trigger conditions or the conditions. Okay, in what are all the conditions we have in the routing methods we have in the traffic manager. So there are 6 methods we have within the traffic manager, the routing method that you can decide. The first one is priority. If you have, say for example, in my previous example, here we have 4 applications. When you decide the priority based, you will tell to your traffic manager, within the Europe region we have 2 application servers, the first priority for the North Europe server and the second priority for the Western Europe server. So any request goes from the European region to the traffic manager. Okay, the traffic manager will always send the traffic to the Northern Europe application server or the app service, because I have decided North Europe application server is the priority one. So if something goes wrong, or maybe the application is not available, then, or the application server is not responsive, then the application traffic will be redirected to the secondary server. That is called as priority based. You see here, use a primary endpoint for all the traffic and provides backup in case the primary endpoint failures are unavailable. So always send the traffic to the very first server. Okay, if something goes wrong, or if the primary server is not responsive or it is not responding, then redirect the traffic to the secondary server. That is called as priority based routing method. The next one is weighted. So when you have multiple things, right, here you can define the weight. You give weight for 10 here or 20 here. When there is a traffic request comes, hundreds people are the request comes, it will send some certain traffic to the application server 1. Okay, and then remaining traffic to the application server 2. So say for example there are 500 requests goes, you can define the first 300 requests go to the Northern Europe, and second more than 300 anything comes, then you route to the Eastern Europe or Western Europe. Okay, so like that you can define the weightage. See here, the weight is an integer from 1 to 1000. The lower the number, higher the priority. Okay, so first one is web application server is 1, maybe the web application server is 2 and 3 and 4, it goes like that. Okay, depend upon the weightage the routing will happen here. Then performance based. If you select the performance based, the traffic manager will, he himself will decide. If there are 10 application server who is responding quickly, very quickly for the traffic manager, he will be the first go to application server. So when you select the performance based, you see here the closest endpoint in terms of the lowest network latency. That's what, highest performance and lowest network latency. The closest endpoint is not easy necessarily close it as measured by the geographic distance. Traffic manager maintains an internal latency table to track the round trip time between the IP address ranges and each data center. Means it is not about the physical distance. Say for example, you have deployed the traffic manager. One application server is there in India, another application server is there in UK. Imagine. So it is not about the distance between two, I mean distance with physical distance between my India and the Western Europe or US. It is about the network latency or network, how many hops are coming between my application server and the traffic manager. Hops nothing but the routers in between. So when you do trace route, first it will go to your house router and then it will go to your network provider router. Between like that in between multiple hops are there. Okay, see, if you want to see, if you go to command prompt and type trace rt, this is a command, and you want to see the Facebook server. Okay, you want to see how much distance is there between your laptop and the facebook.com server. See here, each and every line item is one hop. One hop is nothing but one stop. One stop is nothing but one router. Okay, it should go to that point and from there and it will get redirected to the Facebook application server. See, this 192.168.0.1 is my router IP address, which is there in my house. Then it will go to the Reliance because I am using a Geo internet here. Okay, Geo fiber. So from there, within the, then it started giving the public IPC. It went to the 10.18. So I don't know what is that. Maybe some edges or some routers in between the Reliance and the internet world. Okay, see, each and every point is called one hop. This is an hop, this is an hop, everything is an hop. Finally it will reach to the Facebook application server. So the traffic manager ensures the low latency. It will maintain, okay, it will just say hi message round trip. If the response is coming, here I'm getting less than 1 millisecond. If you say here 6 milliseconds, here it is 5 milliseconds. So what it will do, traffic manager sends the query and it will make a note of the latency table. So whatever computer or whatever application is responding very quickly, okay, it will consider that as a go to application server, and the traffic will get routed to that particular application servers. The traffic manager decides based on the low latency table that it maintains. Okay, you see here in my case I was tracing to facebook.com, right? Initially it went to my local router which is there in my house. Finally it is edge star mini shv 02 tier3.facebook.com. It's an edge server. Facebook has got multiple edge servers across the world which is hosting an application. Okay, you can just take this name or you can just take this IP address and browse, your application will get browsed. Okay, this is how the traces will happen and it identifies the traffic network latency. Okay, so that is called as performance based. So whatever applications are responding fasterly or quickerly, it will consider that one. So next one is geographic. The routing based on the geographic location their DNS query originates. So normally this is what happens. So if you select geographic, as I told you, whatever regions you browse, and locally if there is any application server, the DNS will redirect that your application request to that particular application server. Means today you are in India, it will go to the Indian server. Tomorrow you are going to Germany, it will go to the Germany server. And day after you are traveling to UK, it will go to the UK server. That is called as geographic. Means routing is based on the geographic location. Their DNS query originates. Okay, when you type facebook.com, whatever DNS server the request goes, right? And that DNS is in which location? Is it in India or UK or US? Then it will send the local application servers and not the Indian server in your case. That is called as geographic. Then multi-valued. The multi-value traffic routing method allow you to get multiple healthy endpoints in a single DNS query response. Means it may send anything. Say for example, you are in UK, and in UK only you have multiple application servers. So you will let traffic manager to decide. There it is not decide based on the latency or performance. So whoever is available, it will just randomly send. That is called as multi-valued. But it will not. It will send to the local only. It is not sending to the original application location. It will send to the local, regional, any of the application servers. Okay, that is called as multi-valued routing methods. The last one is subnet. When you select the subnet based routing method, it will identify from which subnet range the application requests are coming. Say for example, if it is coming from 192.168.0.0/16 network or subnet, then send to the Western European application servers. If it is 10.0.0.0/16, then send to the maybe some other application server. So like that, based on that subnet, if you want to send that particular traffic, then you can go with the subnet based routing method. So these are all the 6 routing methods we have with respect to the traffic manager. Okay, that's about the traffic manager. So I'm going to show you how to create the traffic manager and web apps and all. Okay, so now let us quickly understand the Azure web apps, because in our solution we also have traffic manager and we also have the web applications. So web applications are nothing but serverless application servers, I could say. You cannot say serverless. Okay, server will be there, but you don't manage the server. See, normally when you want to deploy an application, what normally you will do, you will build a server, you will install the operating system, and within the operating system you will install the application and do the configuration, everything. So here the installation is also will be done by you, configuration also will be done by you, and if you want to do monthly maintenance, like monthly maintenance service will be there, right? Like patching or any kind of upgrades, all those things will be taken care by you only, since it is a infrastructure as a service. Because it's an infrastructure as a service, you have to own all these activities. But the web app is not an infrastructure as a service, it is a platform as a service. Means when you say platform, Microsoft will give you readily available platform to you. So you don't have to worry about the installation of the operating system, buying the licenses, doing the maintenance activity, doing the upgrades, all those things. Microsoft only manages everything. You just go to the Azure portal, go to the web applications and create the web application. That's it. You decide what language you wanted. You want a .NET base or a Ruby or Python or a Node.js based application. You can just create in a very 2-3 clicks, and you can deploy the application within that. That is called as web application. So web application is a platform as a service based application where you can deploy the application directly to the web service, but you are not supposed to manage the servers. So you see here, the Azure App Service is a PaaS service for hosting your web applications. The web applications can be anything. It can be REST APIs or mobile backends, or you can develop in any language like .NET, Java, Ruby, Python, PHP, Node.js. Any languages you think, anything can be deployed in the web applications. Okay, it is a tool or language agnostics, I could say. So there is no limitations. That is called as web application. So benefits. It supports multiple languages. Okay, so in normally what happens, if you have a server, you have to plan properly. If you want to go with .NET base, you need to have all the .NET modules, and you have to set up the .NET platform there. Java, again, you have to all the Java plugins, required application, everything you have to. But here it is not like that. You don't need to prepare anything. You just write the application, deploy it. That's it. It will take care. And it is a DevOps optimization, means you can even use DevOps based deployments. You can just build the web application using infrastructure as a code, and you write in a CI/CD pipeline and trigger the pipeline. The application automatically goes and deploys into the web applications. So continuous integration and continuous deployments. Tomorrow you want to make some changes. Say for example, today in the Facebook application, the reel size maximum is 1 minute. Tomorrow, the application teams wanted to bring some changes and they wanted to allow the length from 1 minute to 2 minutes, the story line length, or maybe they want to reduce from 1 minute to 30 seconds. They can make the code changes and they can just trigger the CI/CD, enable the CI/CD without disturbing anyone. The code will go and deploy in the application servers and they can make the changes. Okay, that is called as continuous integration and continuous deployments. Means you don't need to have the downtime. You make the changes and you trigger it, it will go and make the changes accordingly. That is called as CI/CD. And global scale with high availability, or scale up or scale down can be done manually. You don't need to worry about increasing the capacity, decreasing the capacity. No, it will take care automatically. And connection to the SaaS platform and on premises also supports. Means if you want to have the connection between your application server or the on premises traditional physical environment, it is supportable. Okay, and security and compliance, authentication of the users using Azure AD as well. You can integrate your Azure AD, SAML, or whatever authentication methods you have. Okay, everything can be used, and you can even enable the social logins. Multiple applications you might have seen, login with your Facebook, login with your Google, that options will also come. Okay, even you can enable the authentication based on the social logins also for the web applications. There is an option you can enable it. Okay, and application templates like Joomla, WordPress, and Drupal. So there are multiple applications templates will be available in the Wixi. All those things are there, right? You can just deploy the applications, bring that applications, and move it to the web applications also. That is also possible. And you can use Visual Studio. You can integrate, you can create the web applications using an infrastructure as a code. You can deploy the application using infrastructure code, and you can just directly deploy using the CI/CD trigger. Okay, you can even debug whatever changes are there. Okay, that is all the benefits you have in the web applications. And when you are building the web applications, there are some service plans. We call it as app service plan. So the app service plan defines a set of compute resources for a web application. You should select some CPU or some memory, right? That is called as the app service plan. You can define what you wanted, what kind of service plan you wanted. You have to define, and based on that, the application service charges will be decided. How much costly your application is, that will be decided based on the app service plan. You want a basic or a standard, there are multiple SKUs are there, we will show when we create it. Okay, and each app service plan defines what is the region, how many number of VM instances you will have, what is the size of each virtual machine instances, and what is the pricing tier. So service plan, I will have these options actually. Okay, so say for example, today you are having two application servers. When if imagine this one of the apps, this application is a Facebook, not Facebook, it is an Amazon or Flipkart. During the big billion day, okay, there in the infrastructure as a service world, we had our auto scaling option, right? There also you have to define it. Here also you can define. Okay, if you are in a public facing applications are there, and whenever there is a critical or crucial requirement comes, your application server should automatically scale in or scale out. There you can decide number of VM instances you want, or what is the size of each and every instances. Okay, that you have to decide in the app service plan. And web app pricing tier, how the pricing will happen. See, there are some two three options are there. Okay, if you want a shared compute, when you opt shared compute, all the startups and people will go with the shared compute, because the same compute, say for example, in the data center there is a application web one server is there, then that server has got around 8 CPU and 16 GB memory. When you opt shared compute, So they will deploy 2 3 applications in the same compute. Even in your laptop also you can do that. Correct. Now you can have web. I mean, you can have your Adobe Photoshop also. You can have. You can have your uh, in DevOps related applications. You can have ISCs. You can also add. You can have your PDF reader. You can have your PowerPoint. All those applications. Multiple applications can be installed. So when you opt shared compute, what they will do, they will deploy multiple applications in the same server, and you don't have visibility with server, and the people also, they don't also visibility on the underlying hardware and the compute, because it is a platform as a service. They will only give access to your application, but backend they will deploy multiple applications in the same compute. That is called as shared. If you go with shared, it is a cost effective, it is very cheaper. See, allocate the CPU to each app that runs on the shared resources. Okay, but the dedicated means whether you are running the application or not, they will give you dedicated instance for you. Okay, and that is little costlier than the shared compute. Then the isolated one, this tier runs dedicated Azure VMs on the dedicated Azure virtual network. When you say isolated, they will keep a virtual machine dedicated for you, or they will keep a web application dedicated for you in a separate isolated instance. They will keep that instance in particular virtual network for you, so there is no communication. So the banking people should be there, critical, security related things, all those things will be kept in the isolated, so that people from the external world, they don't have any connection between your um, network. That is called as isolated means, right, they don't have any connectivity between the other external world, they will be isolated somewhere. So the banking sectors, security sector, and defense, military, these kind of workloads, they will keep in the isolated thing actually, because the cloud itself is a public, because we are accessing the application using internet, and they will allow you to deploy the applications and resources using internet. That means somewhere people will have there in mind, okay, it is not safe. So if that is the case, what they will do, they will prefer your application to be in an isolated network. That is called as isolated. Okay, so the prices will vary. The shared is less, dedicated is little costlier, and isolated is little costlier than the dedicated compute. So according to your requirement, you can decide and deploy your applications. Okay, so that's it about the app service and the traffic manager theoretically. So let me stop the recording and then we'll start with the deployment. Thank you.